Good morning, first graders, and welcome to April Number Corner. Let's jump right in. As always, we're going to start with our calendar. Today, it is April 29th, 2020. And when I turn over today's calendar marker, it looks a lot like an egg. If we were going to use our math vocabulary to describe this shape, we would call it an ellipse. Let's take a closer look and decide why is an ellipse different than an oval in this case. Well, one thing I'm noticing right away is this part is wider than this part. Do you ever notice that when you hold an egg or get an egg out of the kitchen? It's a little narrower at the top and wider at the base. That's what I'm noticing about this shape here. It still is like an oval in the sense that it has that one continuous side. There's no corners or straight sides on this shape. But it's different in the sense that the width on this side is different than the width over here. Where an oval, it's going to be equal widths on each end. It's wider on this end than it is on this end over here. Knowing that, do you think this shape is going to have symmetry? Let's divide it and think about that right now. When I divide this shape vertically, I'm noticing those sides aren't lining up. Just like we talked about, this side of the shape is wider and this side of the shape is narrower. So if I were to fold them, I would get excess shape. It wouldn't exactly line up. But let's see what would happen if we divide this shape horizontally instead. Does that half look the same as this bottom half? Yes, it does. If we were divided horizontally, those two sides would line up. So this shape does have symmetry. Let's add that to our calendar observations. We saw an ellipse today. The ellipse could get divided in half. And yes, it does have symmetry. Ooh, we've had 2 days in a row with shapes with symmetry. Do you have a prediction of what we might see for tomorrow's shape? We'll have to find out. All right, my first grade friends. Today is a special day. It is the 140th day of school. Oh, I'm so happy to hear some of you saying this. We have a decade. We have another group of 10. So let's cover that up. Perfect. We know when we get a group of 10, we can just count it right away as that group. We don't need to count it by its individual parts. Count up the days of school with me, first graders. 100, 110, 120, 130, 140. First graders, how many more days until we would get to 200? You're right, 60. We know 4 plus 6 makes a group of 10, and that's the same when we're thinking about groups of 10. 4 groups of 10 plus 6 groups of 10 would equal 100. So 40 plus 60 equals 100. If we were at 140 and added 60 more, it would equal 200. This decade day is going to be a little different. We don't have a decade day page. We're not going to spend a lot of time writing those decade day equations, but I do want you to pay attention what happens when I turn 139 into 140. So we're going to type into this box and change those numbers. I want you to think, how does that affect the number of 10s you're seeing? You're right, we no longer have 3 groups of 10, but we have 4 groups of 10 or 40. How many 1s did we have left? You're right, 0. When we think about this number, 140, we used to have all these loose 1s on the side, but those have joined together to become another group of 10. So my number in my 10 spot has increased. I went from 3 groups of 10 to 4 groups of 10. Or I went from a group 30 to a group of 40. All right, first graders, thank you for those of you who sent me in your estimations. Now, I couldn't fit all of them onto the screen, but I wrote down and recorded the estimations that I saw the most. So most first graders were estimating one of these numbers. It's our job today to count up how many popsicle sticks we have and rule out any estimations that weren't very close. All right. I've rearranged our popsicle sticks. So I see my groups of 10s, but I see all these single popsicle sticks. Now, first graders, do you think it's going to be the best use of my time to count all these out by one? Or do you think we can make a group of 10? You're right. We can make a group of 10. Can you count these individual sticks with me as I do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there, we have a group of 10. So I'm going to make a trade. I'm going to take those loose sticks away, and I'm going to add another group of 10 instead. Let's count up how many groups of 10 we have so far. 10, 20, 30, 40. We're already at 40, and I see some more sticks on the side. Do you see any estimates I could cross out or take away because they're either too high or too low? Right, we can take away 30. That is way too low. Right away from the start, we had more than 30 popsicle sticks because we had 3 groups of 10, but then we had a ton of single sticks. 100 is going to be way too big. 100 is 10 groups of 10, and I can easily tell we're not going to be able to get there. Can you shout out some more numbers that you think are either too big or too small? 85, 79, 65. We're kind of I'm hearing some friends saying, like, I don't think it's going to get to the 60s at all, and not even probably the high 50s. We know there's more than 4 sticks there, so 34. And 36 are too small. We see this number 40, but I see extra sticks, so we know we're going to pass 40. We're going to stop there, and we're going to keep counting on. Let's recount our 10s, and then we're going to switch over to counting by ones. Are you ready? 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48. Now that wasn't an estimate that I put up here, but we're going to record it because we had exactly 48 popsicle sticks. Now, when we're estimating, we're not necessarily looking for the exact amount. We're trying to think and get as close as we can. Right now, do you see any estimates that were close to 48? Well, 50 was really close. 50 was only 2 away. That was a really solid estimate. And that's the same with 45. 45 was only 3 less. It was a really close estimate. What about 52? When we're thinking about close estimates, we're trying to get within 5. You're right. Let's count on to see how far away 52 was from 48. So we're going to 48, 49, 50, 51, 52. It was only 4 away. It was a close estimate. Let's do the same thinking with 43 and see how far away 43 was from 48. Well, I know if I was going to count on, I'm in the 40 range, so I can really think of it as 8 minus 3. And I know 8 minus 3 is 5. That was a close estimate. Wow, first graders, we had some really close estimates this time. Remember, when we're estimating, we're trying to get as close to the number as we can, but it doesn't mean I need to think of the exact number. I knew the number was going to be greater than the 30s because we had 3 bundles of 10, but I saw a bunch of extra sticks. I knew it couldn't be a lot more than 50 because I know that in a bundle it's a group of 10, and it didn't look like that many extra sticks. All right, first graders, very nice job. The last thing I want to talk to you quick about is your seesaw activity for the day. You're going to have another number corner page where you are going to be solving equations, or you are either adding or subtracting groups of 10, or, let me make one quick change, adding and subtracting groups of 1. Now, I want to just give you a reminder of how to use that number grid. When you are adding and subtracting groups of 10, you're always going up and down that column. When you're taking away groups of 10, you're moving up the column. Those numbers are getting smaller. When you're adding groups of 10, you're moving your way down the column because your numbers are getting bigger. When we're adding and subtracting 1 from a number, we're moving across the row. As numbers get bigger, and I'm adding groups of 1, I'm moving to the right on my row. As numbers get smaller and I'm taking away 1, I'm moving backwards or to the left in my row. Use those tricks when you are going to solve those equations. It's just like what you did last week. You're going to be circling the answer in the color that matches the equation. All right, first graders, nice work, and we will see you tomorrow.